Alright, well, another thing I was planning on doing was I don't have one big charger right now for the battery pack, but I do have 6 of these 12-volt chargers, and they're isolated, so I can just put these in series. But one thing I was worried about is that if I go ahead and put these in series, when I connect them up to the battery pack, how do I know that the same voltage is going to show up across each one? Like, how do I know that 20 volts isn't going to end up on this one and 10 volts on that one or something? So I looked at did a quick look at the data sheet, and they're supposed to have some kind of over voltage protection circuitry in there. I honestly don't know what that means, so I'm gonna just pop one of these open and take a look inside. So we're gonna take a look inside one of these babies to see what's in here. Alright, so here's the back end of the charger. Sunil Canada, 90 to 130 volts input. It's a model 1206S. Output is 12 volts at 3 amps. And it's got 2 LED colors, green and orange. And that's about it. Apparently it's got a fuse in there. I guess we'll see. Alright, so here's the charger pulled out of the case. There's only 2 screws that held it together, so it's really easy to take apart. So here's the back side. It's just a single-sided board construction, which is pretty typical for any kind of power supply. So you can see here just the isolation barrier between the input here on the right side and the output here on the left side from this transformer here. So I've been trying to figure out if there's any kind of over voltage protection on the output here, and so far I haven't really seen anything other than maybe this heat shrunk glob here. Not sure what's in there. So at first glance here, all the capacitors are rated for 25 volts except for just that one right there, which is 16 volts. So yeah, I know the output can't take any more than 16 volts then with that capacitor. So I'm really not sure where the over voltage protection is. It might be just in this heat shrink blob here. It might be some kind of MOV or PTC. I'm not really sure. Might just have to put a couple of these in series and hook it up to some kind of high voltage power supply or higher voltage power supply just to see what happens, whether they share the voltage fairly equally or not. Because I don't really have any other way of determining it from just looking at it here. I can't see any kind of protection circuitry at all. So, alright, so I just put that charger back together and I went and grabbed another one. They're both just connected in series right now, and I'm measuring the voltage from the midpoint here. So when I measure from the midpoint to the positive and negative on the battery here, I can see the individual charger voltages. So as you can see here, this is what I'm worried about. This one's at 5.3 volts and this one's at 5.49. So I guess what I'm worried about is that once I have 6 of these in series connected to a high voltage battery pack, one of them might get overstressed with too much voltage and just blow up, since there's that 16 volt capacitor on there. But another thing to mention, I guess, is that the voltage on these right now is too low to activate that over voltage protection circuitry that's in there, if there is any. I'm still not sure about that. But if there is something in there, then that probably wouldn't activate until at least 14 or 15 volts or so. So yeah, I'm really not going to be able to figure out what's going to happen until I put 6 of these in series and connect them to the battery pack. For sure, when I first hook them up, I'll hook them up through a big resistor so it'll limit the current, the inrush, and hopefully they'll share the voltage evenly. Otherwise I'm going to end up with a toasted charger or two on my hands, I think. So yeah, I'll just have to see what happens.